Hey guys, happy Friday. I know you did a little Edpuzzle video on 8.4 yesterday, but I thought I would just go through it with you one more time before we do a little project to wrap up Chapter 8 on composite area. It can be a little hard to visualize, so that's why I wanted to just do this one more time with you. Super important that you are writing this down and trying this on your own. Because on the practice it's going to be pretty tricky if you're just watching somebody else do it. So as you know, this lesson is about finding the area of composite figures, and the word composite is just meaning that it's composed of several different shapes. So we have to know the area of the basic shapes: rectangle, triangle, square, trapezoid, parallelogram, things like that. These are all things that you learned last year. And if we can remember that, then the rest is pretty easy. So, okay, getting started on example 1. The book does kind of a crazy way for this one, but I'm going to show you something that I think makes a little bit more sense. You can tell this is obviously an irregular shape. There's nothing that we can call this other than 1, 2, 3, 4, 5, 6, 7, 8 sides. It's an octagon. It's an irregular octagon. But there are lots of shapes within this, so just what kind of pops out in, for me, this is what I see. You may break this up differently, and that's totally fine, but got to break it down into shapes that you know how to find the area of. Technically on this one, like the book shows, that you could just count the number of boxes and then count these ones as halves, but I figured we would just get started on this strategy to begin with. Alright, so first of all, I'm going to use some different colors here. I've got this rectangle, and I know that for the area of the rectangle I'm doing length times width, so I see 1, 2, 3, 4 here. 1, 2, 3, 4, 5, 6, 7, 8 there. So I'm going to do 4 times 8, which is 32. And I'm going to circle that because that's the first part, or one of the parts. This triangle right here has a base of 1, 2, 3, and a height of 1, 2, 3. So I'm going to do 3 times 3, which is 9, but don't forget to cut that in half because it's not a full square, it's half of a square. So that's going to give me 4.5 for this piece. And over here I've got another triangle. This one is 1, 2 by 1, 2. So 2 times 2, which is 4. But don't forget to cut it in half, and you'll get 2. And then the last one on top, it's getting kind of muddy here, but you can see that it's a 3 by 3. 1, 2, 3. So that's going to be 3 times 3, which is 9. And then you're just going to add up all of your pieces. So we had 8, 2, 9, and 4.5. Oops, I lined that up wrong. Let me try that again. This is my whole number, 4.5. The rest of these are nothing. I'll just fill in that place value. Alright, so that's going to give me 8, 9, 10, 19, 20, 21, 22, 23 and a half. And then since I don't know the unit, I'll just put units. Don't forget that it's squared, since we are literally talking about squares. Okay, so try that on these two. Oh, you know what? Actually, let me pause for a minute here. I missed something. Oh, I hope you caught that mistake. Okay, I had 9. I put 8 here instead of 32. Oh, I was thinking that was a little bit small. Here we go. Okay, so I looked at that instead of looking at this. So let me just double check again here. I have 2, I have 9, I have 4.5, and I have not 8, but 32. Okay, so we should have 9, 13, 14, 15, 16, 17. So that's 47.5. Sorry about that, guys. Okay, now try these two on your own, and when you're ready, come back, and I have not worked them out yet. I will work them out for you to follow along with, just so it's a little bit clearer. Okay, here we go. For the first one, what I see, and again, you can break this up differently, it's totally up to you, but I see a square, a rectangle, and a triangle. So this piece right here is going to be 2 by 2, which is 4. This piece here is going to be 1, 2, 3, 4, 5, 6 by 3, and that's 18. And then the last piece, I already counted this, so I know that this is 6. That's one thing that you have to pay attention to is, it's a rectangle, so you don't have to count that again. That's 6. 1, 2, 3, 4, 5. So 6 times 5 divided by 2, which is 15. And then add them up. We have 15 plus 18 plus 4. 15 and 4 is 19, so I'm doing 19 and 18, which is 37 units squared, or u squared. The second one, I see, there's a lot going on here. Lots of different shapes. And again, I know you can do this differently, but this is just the way that I'm going for. So this rectangle right here is 1, 2, 3, 4, 5 by 2, and that's going to give me 10. This little triangle here is going to be 2 times 2, divide by 2. That gives me 2. This one's also 2, it's the same thing. Alright, this rectangle down here is the same as the one on the top, so that's going to be 10. And then I've got this rectangle right here, which is 4 by 3, and that's 12. Triangle here, 3 by 3 divided by 2 is going to give me 4.5. This rectangle is 2 by 3, so that's going to give me 6. And then one last triangle, that's 3 by 3 divided by 2, so that's 4.5. So a lot of these happen to be the same. It's very symmetrical. So if we put together the pieces that are the same, we have 4.5 and 4.5, which is 9. We have 10 and 10, which is 20. We have 2 and 2 right here, which is 4. And then we have this last little piece that doesn't match up to anything, and that was 6. So if we add all that up, that's going to give me 10, so 19 plus 20 should be 49. Let me just double check really quickly that I got everything. And one last guy that I almost forgot was right there. That should be a 3. And that gives me 51. Sorry for the mistakes there, guys, but hopefully that's a learning experience. So this one is 51 units squared. Okay, now let's get into example 2, where we're throwing in the circles into the mix and the half circles, as you can see on this one. So this looks kind of funny because the basketball court has this circle and this rectangle, but you obviously wouldn't want to count this area right here twice because it's part of the circle and the rectangle. So what we're going to do is, just if we shade it in, actually the whole thing, we see that it is a semicircle. So I'm going to kind of outline that to show you that we've got a rectangle and then a half circle. So we'll start with the area of the rectangle, which is 19 by 12. We get 228 for that part. And then the semicircle, again, this is what I was referring to before when you have to look at other dimensions. the diameter is given, even though it's not shown. It's the same as this part of the rectangle, right? Because those are both of your sides. So if this is 12, then this has to be 12. And remember, to find the area of a circle, you're going to do pi r squared. So if the diameter is 12, we'll cut that in half for the radius, which is 6. So we'll do pi times 6 squared, and that's 36 pi. And then don't forget, we're going to have to divide that by 2. So let's do 36 divided by 2 first, which is 18 pi. And when we multiply that out, we end up with 56 and 52 hundredths. This, I just want to go back to this for a moment here just to show you why I chose to do this part first. If I were to multiply 3 and 14 hundredths by 36, I'd be dealing with decimal that I would then have to divide by 2. So I just thought it was easier to do this part first and then multiply by pi. Alright, so in the end we have 228 plus the 56 and 52 hundredths. Again, don't forget to line up those place values. So it should be 284 and 52 hundredths feet squared. I just want to go back and make sure I put, oh yeah, okay, units, making sure. All right, one more example and then 2 more to try on your own. This example is crazy looking. I would have no idea what to even call that, but they give you all of the dimensions that you need in order to find the area. So let's take a look. They've actually separated it for us, which is nice. Usually they don't have these dotted lines here, but they put it there just to kind of help us out. So really pay attention to what they're labeling. They're giving us an easy one on this one, showing that the length of this rectangle here is 8 and the height is 4.5. So let's start there. We have 4.5 times 8. So that's 36. And then you may see this as a triangle, but the problem, and this is what I'm referring to here, this parallelogram, the problem with this, if you're looking at just this piece of the triangle, is you don't know what the base is. You only know that the whole thing is 8. So you really can't break that up into a triangle. You have to use the parallelogram. But a parallelogram is basically just a slanted rectangle, so as long as you know what the vertical height is, which they've given us, and the base is, you're fine. So the quote-unquote formula, you know how I feel about those, but would be the bottom times the true height. And so in this case, it's going to be 6 7/10 times 8. That's going to give us 53 6/10. And then the last piece of this is the triangle over here. Again, they were really nice on the dimensions. I'll do that in a different color. They gave us the dimensions. There was really nothing that we had to find. So we're going to do 11 2/10 times 4 5/10. And we'll get 50 40 hundredths, or 4/10. And then don't forget that we need to divide that by 2 since it's a triangle. That's the part that people always forget, because you do all the math and then you forget. So that ends up being 25 2/10, or 20 hundredths. So we're going to add all of those things up, do this in another color again. So we have our 53 6/10 right here, our 36, I'll just fill in the place value, our 25 2/10. They were 1, 2, 3. Okay, so we got them all. And then we add that up, we are going to get 11, 12, 13, 114 8/10 centimeters squared. Okay? Alright, so now try these two on your own, and again, come back and I will work them out so that you can see exactly what I'm doing here. Okay, so for number 3, rectangle, 9 times 7 is 63. And then they didn't show you directly what the base is, but you know because it's going to be the same as the other side. So this is 9 times 6, which is 54. But then, 54 divided by 2. Is 27. Is that right? 27 and 27. Yeah, that's right. Okay, so the 27 plus the 63 gives us 90 meters squared. That was for number 3. And for number 4, one thing to notice on this is that all of the semicircles are the same, so there's really no need to do this 4 times. We'll just figure out 1, and then we can multiply it by 4. That's one strategy. Or I guess you could just treat these as 2 circles. Like if I put this piece together with this piece, and this piece together with that piece, I have 2 circles. Either way, you would be fine. But then notice that the middle is a square, because this is 2, 2, 2, and 2. So the area of the square, 2 times 2 is 4. So that piece is done. And then the rest of them, if the diameter is 2, that means the radius is 1, because 2 divided by 2 is 1. So we'll do pi times 1 squared, which is just pi, 3.14. So if you have 3 14/100ths for one complete circle, and you would just need to multiply that by 2 to get your 2 complete circles. And again, my strategy was just to put the 2 circles together. You could have divided that by 2 if you wanted to, and then multiplied it by 4, but I just think this is easier. That would be 6 28/100ths, which then you would add to the 4, and you get 10 28/100ths feet squared. Okay guys, let me know if you have any questions about this, and have a wonderful weekend.